Hola, ¿qué tal? This is awesome, right? So good. Let's do one more huge round of applause for the organizers and everybody who makes this possible. It's really, really good. Okay, so while we get set up, I'm going to talk about layout in SwiftUI. And I think, so it's very different from UIKit, right? Like in UIKit, we have basically two main methods of doing layout. We have frame-based layout and auto layout. And both have their pros and cons. And in SwiftUI, we have a third method, and basically the only method, and that's the layout system of SwiftUI. And since SwiftUI came out, I jumped on it and started playing around with it a lot and working with it. And I have to say, I think the layout mostly is very easy if you can do what SwiftUI wants you to do. But there are some things that are hard. And today we're going to work on an example that's easy in UIKit but hard in SwiftUI, and we will learn the layout system as we go. So I have this very simple view here, and it has a text, and we can run it. It's on an iPad. It's a little bit small, but don't worry, you don't have to read the text. Now, what I want to do is build a button that looks like the button in the stopwatch app. And the main challenge is having like a round button that sort of fits around the text. So we can give it a try. So the first thing we can do is say background, circle, and then do a fill and color it blue. So this is what I would expect at first. So SwiftUI has all these nice things like background and circle. And if you run this, it looks very strange. I guess you can see it. This is not at all what I would expect. And to understand why this is happening, we need to understand the layout system. So let's go back to our text and consider what the layout system is doing. So there's 4 steps involved. So when SwiftUI wants to lay out this root view, the first thing that happens is the container proposes a size. And that's the entire size of the entire iPad, basically, without the save area. It's only the save area. And then the text says, OK, I'm going to take that size and lay myself out. And the text is very small. And the third step is the text reports its size back to the container. And then the container can center the view. And this 4-step process is basically what happens with every view and subview. So you propose a size, the view sizes itself according to that proposed size, then the view reports back its size, and the container centers the child. And of course, there are lots of ways to override this and change this, but that's the basic layout algorithm. Now, let's consider a few other things. I'll remove this for now. Let's see what a circle does. So this is interesting. You can just write circle as your view, and this will work. And this makes basically a full-screen circle. So what happens is the layout system proposes the entire size of the iPad, and the circle tries to fit itself inside that proposed frame or the proposed size. If we rotate the iPad, we see that it becomes just a little bit bigger because now it can go all the way to the edge. But that's the behavior of circles. So it fits itself inside the proposed frame. And we'll do one more primitive, and that's color. So a color is a view as well. And what a color does is it takes the proposed frame and basically fills that in the color. So here you can see nicely the save area, and the color just fills itself to the proposed size. OK, so now let's go back to our circle with a background. So we have the text, reset, and for now I'll just do as the background, color the blue. And now let's look at what's happening here. We have the text. It's a bit hard to see with the contrast, but there's a blue background. And this is sort of what you would expect, right? Like if you write background color. And to understand how the layout works, I made a little helper. And so you can write .mirror. That's my little helper. And if we run this, we'll get a tree of the view hierarchy. So here we have our view hierarchy. And let's consider what happens here. So the background has 2 children, the foreground element and the actual background. So when SwiftUI proposes the layout, it proposes it to the root view. So that's the background. So it proposes to the background, this is the, render yourself in the entire size of the iPad. Then the text receives that same size from the background. And then the text lays itself out. And the text says, well, I was only like, I don't know, 50 pixels wide. So it reports back to the background those 50 pixels wide and the, I don't know, 13 high. Now, what's happening is very interesting. The size of the text is the proposed frame for the background. So the color receives the size of the text as the frame, and that's why it draws itself inside that little size, and that's why it works perfectly here. So then the color lays itself out, and now the other thing that's important is what the background does. It also needs to report a size. Every view needs to report a size back. And the background reports always the size of the text in this case, so always the foreground element. The background completely ignores what the color is doing. It always returns the size of the foreground element. So that's how the layout works. Now, if we go back to our circle and fill it, it sort of makes sense, maybe. So we receive our background, so we receive a proposed frame. The text lays itself out, and it returns like a small frame, right? And then that size is proposed to the shape view, so to our circle. So the shape view fits itself, or the circle fits itself inside the little box of the text, and that's why the circle is so small. So this size goes to the background, to the shape view, to the circle, and then it lays itself out. Now, how do we fix this? Well, one thing we could try is give this circle an explicit frame. So let me indent this a little bit. So we could do like frame, and they say width 75, height 75, and now it looks like we're almost done. I mean, we need to make the text white and everything, but this looks good. This is sort of the end result that we want. But it's a little bit problematic. So if it's just this one view, it's fine. I'll remove the mirror, and I'll put this into a variable. So now we're going to make an H stack with 2 of these buttons inside. So let's fix the T. Like we have 2 buttons, for example. Now, return it also. We'll see that this doesn't work quite as expected. So the buttons overlap. And it's even worse if we change it to a V-stack. So if we change it to a V-stack, there's even more overlap. And why is this happening? And again, we need to understand the layout algorithm. So I'll remove the V-stack and return buttoned mirror. And I will go through the layout process once more. So we start with the background. We receive, like, I don't know, like a large size. The text lays itself out. It returns its size, and that's the size that's reported to our frame. So what frame does, it ignores any proposed size. In our case, it's going to propose 75 by 75 to our shape view, because that's the width and the height we define. So that lays itself out, and then the other thing that frame does is when it knows the size of its children, it ignores that. It always returns 75 by 75. So then we go back to our background, and if you remember from earlier, the background, it doesn't care what you do inside the background view. It only always returns the size of this text. So that's why sort of the size of the entire view is going to be the size of the text. And in a way, you could think of it as the circles being drawn out of the bounds of the view. So that's a little bit problematic. So how do we fix that? Well, one thing we might try is to move this frame modifier outside and sort of do it, like maybe try to do it over here. So something like this. So I'll cut it and paste it, and like we'll do it after the background. And this is almost working, but now we are back at the beginning. So what's happening here? Well, we receive the size of the iPad in the frame, and the frame ignores it. It says, I'm going to render my subviews with 75 by 75. And that gets passed to the background, to the text. The text returns its size. Then we go back to the background, and then the shape view uses the size of the text. It doesn't know about the 75 by 75. So somewhat counterintuitively, we have to move our frame over here. So we set a frame on the text. And now, if we run it, our button looks okay, like this. And it sort of makes sense from the layout perspective if you see the tree or if you have it in your head. So we receive some proposed size. The frame tells, well, I don't care about the proposed size. It tells the text, lay yourself out in 75 by 75, so the text does that. Then whatever the text returns, the frame doesn't care about it. It says, well, I was 75 by 75. And that gets passed to the shape view, so that's why the circle is drawn in the right size. And then the background, it doesn't care about the shape view. It only returns the size of this frame, right? Because it always returns the size of its foreground child. And we can see that it now works in a V stack and an H stack. Hopefully. So it works in the V stack and in the H stack, and everything seems to be fine. But then it works if you have you have the text reset and stop, but then when you localize, you're going to have a problem, because if you would localize to German, you always have these long words, right, or multiple words. Like, let's say it's like this. Now, all of a sudden, our button doesn't look so nice anymore. We can see that the text fits itself inside that 75 by 75, but it's not great. And it gets even worse if we do dynamic type, which a lot of people have enabled by now. So now nothing fits anymore. OK, so how do we fix that? Well, the first step, this is going to take a while. So the first step is to use fixed size. And fixed size, what that does, it's a modifier specifically for text. And it tells the text, just be as wide as you want to be. Like, ignore the proposed frame or the proposed size. So then, let's see what this looks like. So now, at least the text, it's overflowing, but it's on one line. And let's go back to our mirror so we can see what it looks like. So now that we should have one more node in our view tree. So here we have now this fixed size node, and that basically ignores whatever you propose. It's going to tell its child, the text, like, you can be as wide as you want to be. So this is getting closer to the solution. What we really would like to do is measure the size of the text. So based on the text, we're going to set this frame to be the width of the text, and also the height is going to be the width of the text. And measuring things is not so easy as it is in UIKit. So in UIKit, you have an object that you can just ask, like, I don't know, what's your intrinsic content size or your size that fits. In SwiftUI, the layout process goes in 2 steps. We construct this structs, this huge hierarchy, and then we send that over to SwiftUI, and SwiftUI renders it, and it makes objects probably under the hood something. But we need a way to hook into this rendering code, so into the layout code. And to do that, I'll comment this out for just a second. The way to hook into the layout algorithm is to use a geometry reader. And a geometry reader is basically like a view that doesn't do anything. It wraps other views. But inside, you can access a proxy, and the proxy contains layout information. So like, we could have a text or whatever we want inside. And inside this proxy, or inside this geometry reader, we can now access the proxy.size, and that's the proposed size. So we could say proxy.size.width, for example. And now we should have a text on screen, and it's 1366. And if we rotate the iPad, we'll see that it proposes a different size, because it's a different layout. So we have most of the ingredients now to fix this problem. We know that we have text, and we have fixed size, so the text will be the fixed size. We know that we can add a background to any view, and that background receives the foreground size. So if we add a background to our text, that background will be exactly the same size as the text. And we have a geometry reader, which we can read out that size, that proposed size. So what if we would put a geometry reader in the background of the text? Then we have like a hack to measure the size. So let's try that. I'll enable this again. So we have a text with a fixed size, and then we use the background, and this will receive the same size as the text. And then we use a geometry reader, and we get a proxy in. And then we need some view here. So for now, I'll just use colored red. And this should still run. We now have a red view. And you can see that the red color is exactly the same size as the text. So if we set a breakpoint, we can actually verify that we have the right size. So we can do p proxy.size. And here we see it's 92 by 20.5. So almost there, but not quite, because we need to somehow store this size of and use it inside the frame. So the first thing we might want to do is like have a state variable in SwiftUI and say the width is going to be a CG float. We'll start with nil, and then we want to use that here at some point. But what we are not allowed to do is something like this. We cannot say self.width equals proxy.size.width, because during the construction of these views, we're not allowed to modify state during this layout process. Now it's not even possible, the syntax, because this uses view builders, this new feature, but there's a way around it, and still we're not allowed to write something like this. So we need another mechanism, and this is a little bit complicated. Let's see if we have a mirror here. We'll look at the mirror and see how we can fix this. So we have this whole layout process, right? Like at some point we lay out the text in a fixed size, and then this gets proposed to the geometry reader. And once we're basically in between the geometry reader and the color, that's where we can measure the size. And instead of setting a state variable, which is not allowed, we need some way to communicate this to the parent views. So basically down the hierarchy or up the hierarchy. So we want to communicate some value from the geometry reader all the way down here. And we can do that using preferences. So preferences are a way to attach a key and a value to a view. And these get communicated sort of up the tree to the parent view. And the parent view can read it out. And already you can see here that we have a view tree, which means that maybe like this view and this view could both define the same key with a different value. So preferences are three things. It's a key and a value, and then a way to combine two values in case there are more than one. So let's do it. We're going to define a size key, and this is going to be a preference key. So that's the protocol. And this wants us to implement reduce. And then we have to specify the type. So we're going to be passing a CG size around, an optional one. And reduce is basically the way to combine two values. So if you have multiple values. In our case, we're only ever going to have one. So I'll just do it quickly and say, well, we're going to take either the existing value, or if it's nil, we're going to take the next value. You can become way fancier, but we'll leave that for another time. So now we can define a preference in our color. So we can say preference, and say size key.self as the key. And for the value, we'll use proxy.size. So now what happens is if we run this, our background, our red color defines a preference over here, and this gets propagated all the way down the tree to the parent. And now over here, we could read out that preference. So we can say on preference, change size key.self, and then we get an optional size in because the type we defined was optional. And we could print it, or we can just assign it, so we can say self.width equals size.width. So if we run it, we're almost there. We still need to use our width. But you can see that now we have one more node in our view tree, so that's over here. It's this on preference change, and that reads out the size. So if we use our width over here and over here, now we should have a button that sizes itself to the text. OK, so I'll remove the red color and make it clear. And now we can see that it wraps exactly around the text, which is not that nice. We'll use a little bit of padding. So we'll say padding 10. And now we're basically there. So let's go through this once again. We get a proposed size. We go all the way up the tree. We get the background. We get the frame. And the first time around, the frame has a width that's nil, because we started out with a nil variable. Now, if you have a nil frame, it's basically a no-op, so nothing happens. So we just pass on the same proposed size here to the padding, to the fixed size, and then the text lays itself out in the size it really wants to be. It reports that size back. The padding just adds 10 points on each side. And then that is passed to the geometry reader, to the preference. It lays itself out. And then at some point, this preference is communicated all the way up the view tree, and somewhere arrives over here. And then on preference change, we change the state, and the entire tree is rendered again. So you have to be careful not to keep changing the state every time you render. You have to make sure that it's no infinite loop. And that's basically how it works. So now we can also see, if we remove the mirror, that we can increase the font size, and our views will update automatically. So let's go for dynamic type. So now it's big, and now it's small. So a few things to take away. When you do layout in Swift, it really helps to understand how these individual views and how the modifiers do their layout. So understanding how text does it, how circle does it, how color does it, and how background does it is very useful. Because there's no good way to hook into the layout system, I've been using this pattern a lot. So I've been using like a background with a geometry reader, a clear color, and a preference. And that's sort of a way to measure views during layouts. And one more challenge for you. If you want to use this in production, if you write SwiftUI in production, but if you want to use this, you're going to have multiple buttons probably, like the stopwatch has start and stop. And these have different labels, and these different labels have different sizes. And if you use this code directly, you're going to have different buttons with different sizes. That looks ugly. So what you want to do is basically apply the same technique. So all these buttons should propagate their sizes up the view tree using a preference, and then at the top, you read out these different sizes, take the maximum one, and propagate it back down. So that's my challenge to you if you want to play around with this. And there's lots more to say, but I hope you have lots of questions, and you're going to have a great time. Thank you.
We're going to do a few questions, if that's OK. We have the time.
Yes.
We're going to do 3 questions. Just raise your hand, and you'll be handed a microphone. And just 3 questions, and then we'll move on.
If you want to ask a question in Spanish, it's fine. Somebody will translate.
Yeah, sure. We have a question over there.
I can speak English, so don't worry about it. Hey, Chris. This is Carlos from Bolivia. We met again sometime from San Francisco, so
Hola.
How are you again? Well, my question is, so you can use the background modifier of the layout many times as you want. So how many you can use of them? It is straight to some limit or something?
Sorry, how many, what?
Yeah, how many backgrounds modifiers you can use on the layout of the circle?
So the thing is with SwiftUI, if you write a background modifier, it does not. So in UIKit, if you set a view.background, it's one property. In SwiftUI, if we go back to this tree, if you remember this tree, it just adds another node in the tree. So you can have 10 backgrounds if you want to, and you have 10 more nodes. So it's not setting a property of the view, it's really adding another node to that tree. So you can have as many as you want to, but probably for performance reasons, there's some, you wouldn't want that, but in theory you could.
So basically you're using one for setting up the preference and other one for use the preference, right?
Yes. Yes.
Okay, thank you. That's why.
Perfect. Any other questions? Someone, come on, don't be shy. Okay, fine, Tiago, just do it. That way.
In the meantime, the diagram is also drawn using preferences. It's just H stacks and V stacks, and then the preferences are the centers of the view that are communicated upwards, and then the diagrams uses those centers to draw the lines. Another use case.
Hey, Are you going to open source Mirror? And secondly, have you ever tried using aspect ratios up to size as a square and as the inner label to stretch?
I found it really hard to work with aspect ratios. They didn't do at all what I wanted, but maybe it's an easier way to get this to work. You still need some way to propagate the size sort of outwards, but there might be easier solutions. As for Mirror, yeah, I would love to open source this. It's not so much code. It's maybe 200 something lines, and the way it works, it's quite cool. So let's quickly run this. I don't know if you can see it still. So basically, what happens with Mirror is I take the type of the view. So you know that almost every view in SwiftUI has type some view, but there's actually a real type underneath, and the type of this. Let's see. Oh, is it running? Oh yeah, I need to use Mirror. 1 second, I'll add it back because this is really cool. Here we go. So this is the type of the view. So it's this huge generic type, and the way that Mirror works, it just parses that type and all the generics, and basically every generic becomes a node in the tree, and if there's more than one generic parameter, it becomes a branch, and this is really just literally the type, and then I simplify it a little bit. But yes, I would love to open source it. Yeah. Okay.
Okay, well, thank you very much, Chris.
Thank you.
Another big clap for Chris.